I'm going to start with apologies. If you read the title of this talk or the write-up, you might have been forgiven for thinking it was maybe a bit to do with sex, or that it would have good toilet jokes in it. When I came to write it, I wrote that abstract a long time ago, and then I wrote the talk this weekend, and I found out it wasn't nearly as funny as I thought it was going to be. So I fear it will be dry. Please bear with me. I hope it isn't too dry. Also, I've put together a presentation which seems to rely on me remembering keyboard shortcuts, which is a shit idea. Is that legible? Yeah, that's all right. Okay. So I've been playing with generators recently. You may or may not. Have you got any Python programmers in the room? Sweet. I think you have generators in Ruby as well, but I don't know anything about Ruby. They crop up all over the place. JavaScript is going to get them. It's going to get them in a thing called Script 6, which is what you will think of as JavaScript in about 2 years' time. At the moment, there's some health warnings. Like, you can't really use this stuff unless you like pushing unstable servers to production, which is what I do. So you'll need, at the moment, we'll be working on Node.js today, and you'll need to run the unstable release.
Is there a stable release of Node.js?
No. No, well, so the story is, I started a project which was going to release, I think, yes, like tomorrow or something, in January. I didn't do it all the time, you know, it's been on and off. And I thought, I can use this stuff because Node 0.12, which is a stable release, as opposed to 11, which is an unstable release, will be way released by then, because they were promising us in January that it would be okay. It's still not out, as those who care about this stuff know. It's still not out. We're all waiting. I've given up waiting. Seems okay to me. So you'll need to run, if you want to do this stuff in Node, you'll need to run 0.11 point something. That can be a bit tricky to do. You also need to run it with an experimental flag called Harmony, which turns on all the ES6 features in V8. So there's 2 bits of experimental stuff there. If you're worried about this, you could look at the Script 6 compatibility table, which a nice guy called Kangax maintains. It'll tell you where this is present and where it's not. You'll look at it and you think, I can't use this shit. If you want to swap versions of Node all the time, can I recommend NVM? The Node version manager is probably the easiest way to maintain multiple Node distributions on your machine and switch between them. It's a really nice piece of kit. And there's a thing called Gnode, which is just Node with just generators, and it makes it a bit easier to run, but I don't know very much about it, and I probably shouldn't have put it on the slide because I can't talk about it. So, as you can see, for this, we are running 11.13 with the Harmony flag. And that's kind of all there is to say about it, really. You probably are thinking about whether or not you can use this stuff in browsers. Yeah, you can. You can use it in most Chrome and most Firefox now. You can't actually use it, though, because, I mean, how many people here only have to maintain those 2 browsers?
We're in a beta.
However, there are some techniques you can use. They seem a bit wild-ass to me, but Google have made this thing called Tracer, which compiles ES5, that is like JavaScript that you know and love, into ES6. That apparently works. I think it must be witchcraft.
Not vice versa.
It's the other way around.
6 into 5?
Yes.
Yes, isn't that what I said? So it does that. I don't know how it does it. Far too clever for me. Apparently it does it reliably, and that will give you code that you can run in almost any browser. There's a thing called Facebook also a type of waiting. They've made a thing called Regenerator, which will also give you, it's a shim really, will give you generators in your widespread browsers now. So you can use this stuff if you don't mind dabbling in the dark arts a bit. And if no one's watching. So the first bit of this will seem extra dry. It's about what a generator function is. It looks like a function. There's one there, just sitting right there. It has a star, which is one of the first feature which really attracted me to this. Was the star. I like that. It doesn't really matter where you put the star. I got really hung up for ages about whether the star should go there or there. I can't find any authoritative source, and I can't really digest the actual specification, which is way too hard for me. My linter doesn't care, so neither do I. That's a generator function. If I called that, what would you expect to happen?
Nothing.
No, nothing. It doesn't return anything, right? Wrong! Wrong! That would be too easy. Let's do that. Hang on. This is where I try and type in public. Oh, you see, it's gone wrong already. And then we'll look at. It's logged a thing, which is kind of wrong, but that's what they do. What generators do is they return a generator object. So this is a generator function, and this is the first bit of unwiring you've got to do in your brain. You've got a generator function, and it returns an actual generator object. Okay. This is quite a language construct which suddenly seems to be quite unlike anything else, because that function clearly, plainly returns nothing, and yet it does. Okay, so what is your generator function? We know it returns a generator. What's the generator object? I wonder if I did, desperately afraid of typing in public. I might have made a macro. Yeah, okay. What we're going to do is we're going to instantiate our generator. That's the technical term. And then we're going to log it, and we should get that little curly brace at the bottom. Then we're going to call a function which the return generator object has, which is called next. And we're going to call that twice. We'll see what happens. Control B. What happens? Okay. We've got the result of calling next on the generator is an object which has a value property, which is currently undefined, and a done property, which is true. So it's telling me that the generator has finished its execution and it has nothing useful to do. Okay, and it's done that twice. Cool. You'll see my linter is also telling me that a generator really ought to have a yield statement, otherwise it's fucking useless. so we'll give it one of those and see what happens next time. This is more typing in public. Yes. What shall I yield? I. Okay. Okay. We've yielded I. That's excellent. And so the value of our first call of next on the generator is I. And is it done at that point? Has it finished? No, it doesn't think it has. It's not sure that it has finished. There might be more to do. And so we get done false. We could probably make this generator finish by, I don't know, yielding something else. No. Yes, that's traditional, isn't it? Look like a programmer at all times. Yeah. Oh. Does that make sense?
No.
Okay, because we think it's finished because we've yielded I and we've yielded bar, but we're still not done. Okay, because the generator will always want to do something else. Ooh. Incompetent typing. Yeah, it's done by then. So this is the first mystery. The first mystery is that there's always an extra call to next, normally at the beginning. And that the generator is running up to the yield statement, and then it's waiting, and then it's waiting for the next statement, and then it's yielding, and it's going to carry on doing that as long as it can find yield statements. Can anyone see an actual practical application for this?
It's coroutines, isn't it? So you can put some code after the last yield and have it execute.
Right at the end. Yeah, so you can do some like tail stuff, some finishing up work at the end if you want
half
to.
a decorator.
Yeah, except I haven't worked in a language with decorators, so I don't really know now.
Not a language.
Yeah, that. It's a bit like a decorator. I mean, I suppose the most obvious application of this, which people talk about quite a lot, is generating infinite sequences. In Python you might call it a lazily evaluated list, where you could just keep asking for another value from the list, but you would at no point have to have the whole content of the array in memory. You wouldn't have to generate all this stuff at all. So this generator, oh look, I've got Dom's laser pointer, says what it does. It's going to generate the Fibonacci sequence for us. This is quite exciting. I found this really exciting when I started writing generators, because you never do this in JavaScript, right? What's it going to do? It's going to stack the browser, and everyone's going to die. But here you can do this. And this is the big lesson, the first big lesson, I think, which is that the generator executes until the first yield statement, and then it suspends execution. It really does actually just stop. It just stops and goes away, and you can do other stuff elsewhere, and it's not going to lock the whole browser or whatever it is that you're running in. So forever, we can keep adding two numbers together and returning the result. Okay, so that's an obvious application. If you want to make a really big list, then you can. So you can see there, if we run that, then it's going to, I mean, we're only doing it 8 times because I think we all know how this ends. But you can keep calling it. So there's the first thing people think about. They say, oh, okay, so I can have these big lists. I mean, and you can probably think of applications for this where you might actually do something in there infinitely. Maybe, call your database or do something expensive, which you don't want to do a lot. And only do it as often as you want, but still be able to do it forever. Right? That's kind of cool. That's good. Are you all with me so far? Yes. Okay, you now know generators. I better go. So, there's some other things to learn. Generators can be consumers. You've not seen this pattern before. You can see there, we're supplying values to the next function, to the next call on the generator. And what's going to happen is they're going to become the value of the statement which is yielded. This is not a very clear example now I look at it, but let's run it and you'll see what I mean. So the first time through, we call the generator, which suspends execution at the beginning of the yield statement somewhere here. We're not actually yielding anything useful, because in this instance we don't care what we give back. We're only interested in pushing values into the generator. And we've pushed the result of the yield statement onto our stack, and then we've console logged it out in a needlessly complicated way, so that we can build up a string using our generator. It's that clear. So the generator doesn't just give stuff back, it also consumes data. That's quite interesting. But there's more. You can throw errors onto generators. This gets really useful later on, but right now it seems like a fairly obvious thing, but from outside we can throw an error onto the generator and it will understand it. So we're trying to yield, something happens to generate an error, and instead of yielding what we're expecting, we catch the error and we can log it. So I mean, I hope this is going to work. Yeah, you are a T-bot. This in itself isn't very useful, because when you're thinking about a generator of something which contains its own code, it's hard to imagine how something outside it is going to know that an error has occurred. But this is going to become really rather important later on, that we can, from the outside, say to the generator, hey, something's gone wrong. Okay? That's all the basics. That's all the basics. How long have I been talking for? Oh,
About 10 minutes.
10 minutes, that's okay. That's okay. So we'll do a recap. Generators, most important thing, stars. They yield values when you call next. They receive values when you pass values into next. They can propagate errors, and we'll find out why that's exciting a bit later on. And they suspend execution, a lovely word, indefinitely there. Okay, you could take a generator, call next on it, it would run up to the yield, and you could leave it there forever, and it would never do anything else, indefinitely, totally indefinitely, after they've yielded a value. That's generators. Fairly, I mean, a curious language construct. What have we, yeah, please interrupt me with questions.
So, no, that wasn't sarcastic. It's probably the wine, but the value that we push into with our next execution, where is that cast into in the generator?
Okay, yeah, as I said, it was a shit example. Let's try doing something like, this will make it clearer, maybe. Except I still can't type. So we're doing the same thing there. So you can assign the result of the yield statement. Here we were pushing it directly into an array. Now we're assigning it to a variable.
So
same
yield
thing
null is the hello that we pass in?
Oh no, sorry. There's nowhere there where we're actually echoing the value of the next call, the result of next.
Yes.
We could do that too if you want. So we could try.
So
So this is when you call yield, it actually returns the value that you're passing in, and null is a default.
You wish. No, it assigns. It will pass out the yielded value. So we'll be logging null here, but it is assigning what was passed in to the result of the yield statement. This console log should make that pretty clear.
Okay. I'm with you now.
Is Frank's question clear to everybody? Because it took me ages, really ages, to understand that on that one line we've got two things going on. We're yielding a value and we're also assigning the result of the yield statement, which isn't the same thing. Okay? Yeah, okay, good.
What about multiple arguments?
Oh, like having lots of stuff yielded. You can do some really nice stuff in ES6 with destructuring. I don't know if anyone's familiar with that concept. Really obvious in Python, where you could do a thing like saying var item and thing equals yield some process which would give back an array of two values, and then you'd have two variables called item and thing in scope, but only with extra language functions, which are also available in ES6, but we're not talking about them today. Are we good? Okay. I'm not sure I am, but I'm glad you are. Okay. So, a little while ago there was a Node school being run in Norwich, and we were talking about callback functions in Node, in JavaScript generally, and Dom of course said, what about callback hell? Which is a bit like saying, jQuery, what about spaghetti code? If you've written anything in Node, especially if you've written anything using asynchronous I/O in Node, which is, to be honest, pretty much the only reason that you'd have for writing anything in Node anyway, apart from the fact it's in JavaScript and it liberates you, then you will have either written or striven not to write code like this. Okay, so let's go through what we're going on here. I've got a couple of little things here. I've got a little geocoder which makes an HTTP request to a service by some guys called Mapit. My Society run a nice service where you can pass a postcode and get back all sorts of stuff. They give you loads of JSON with stuff in it. We care about the latitude and longitude represented by the middle of the postcode today. That's what we care about. Then there's an API called the Great British Public Toilet Map. What? And this is a tiny skinny wrapper around it. One of the things, in fact the only really useful thing that the Great British Public Toilet Map does is to take a latitude and longitude and give you a list of loos near it. This has taken me 3 years. It's an incredibly hard problem to solve because nobody knows where the loo is. Okay? When I've run out of material, I will pad this talk by talking about the loo map. Okay? But only when I've run out of material. So simply, we're writing a game here. It may not look like a game. It's a game. It's a game where we give two postcodes, and the winner is the one which has the most public loos within a kilometre radius. Okay? That's the game we're writing. And you can see we've written a function for our game. It's called compareify, because all good JavaScript ends in ify. And we're going to pass it in two postcodes, because that's what we want to do. What do we have to do to make this come true? First of all, we have to geocode the first postcode to give us a longitude and latitude. And we're going to store that somewhere because we'd quite like to be able to put this data out somewhere later on. Then having got that, oh yeah, it does already feel quite contrived, we are going to look up that longitude and latitude against the Great British Public Toilet Map, which should give us JSON representing a whole pile of loos. Oh yeah, so now we've got those two. We've got postcode A sorted out. Now we've got to do postcode B, and we're descending into the stack. Now don't get me wrong, there are many better ways of writing this code. Okay, but you want an example of what callback hell can look like. This is classic, isn't it? And then we're going to do it again for postcode B, and we're going to assign those results, and then we're going to go and get the results for the loos for postcode B. And right at the end, right in there, we get to log the results, and we are in the depths of hell. You can see that this code works, assuming that I've got an internet connection and the API I wrote as it's stacked. Yeah, okay, good. So you can see that in the square kilometre of my home in Rowton, near Cromer, there are no public loos. That's because all we have is corn and cows. But near our office, in the thriving heart of the metropolis, we have 5 public loos. Everyone understand this code, and everyone see why this is not necessarily lovely. Okay. Let's think about another way to write it using generators. And this will use, I think, all of the features of generators that we talked about a moment ago. I think we pass in values, get values out. Yeah, that looks better. So what we're going to do is we're going to make a generator function. We're going to do some tricks in here. I'll try and explain them all the way. It might get a bit non-linear. I'll go backwards and forwards, confuse myself. You laugh at me. Well done. I got the point. So what we'd really like to be able to do is just to iterate over a list of postcodes. Look, we've already got nice, now we can do an infinite number of postcodes simultaneously. Game's better already. We're going to loop over that, and we're going to assign some variables. We're going to say, hey, for each of those, we're going to yield we're going to geocode it and yield the result. We're going to get a list of loos, but that can't possibly work, can it? Because we have to know the longitude and latitude to pass in there, but that's what variable assignments work like, right? In synchronous code, you could do this. Doesn't this look like proper programming with synchronous code, everything laid out in an order? Yeah, it does. That's kind of nice. It's refreshing. And then once we've done all that, we can quite simply just assign those results onto the thing and log them. So that would be really lovely. That would be how it's supposed to be. And you can do this. There is a little sleight of hand involved, however. A couple of things which need explaining. One of which is we have to have something to coordinate the actions of our generator. We've got to have some kind of I guess I keep wanting to say controller, which is where you discover that I'm not a computer scientist. But something which is going to orchestrate what the generator is doing and coordinate its results. I wrote this in order to make an obscure joke about the Industrial Revolution. Here's a generator coordinator function, probably the simplest one I could figure out how to write. It contains no error handling, it does nothing special. There are much better ones out there that use nothing like this. But we're going to take a generator. I'm going to scroll down a bit. There you go. So here's how we're going to invoke it. We're going to call this function. We're going to pass in our generator function, which we're going to invoke with the arguments which we wish to pass to it. So this middle section here is going to return us a generator object, right? Then we're going to call next item. The next item is just going to keep getting values out. It's going to call next on the generator and see if it gets a result. And then if it's not done, it's going to pass in whatever it got back to the generator. And it's just going to keep doing that until the generator says it's done. There is one bit of sleight of hand. I'm going to have to go back up to the top to explain that. Has anyone ever heard of a thunk? Yes.
Something like that.
Yeah. Okay. So in Node you're used to callbacks, right? With which normally take in the classic Node pattern is you take an error or you take a result. And normally you'd sniff the error to see if something had gone wrong, and then you use the result if it hadn't. Classic pattern. The trouble is that doesn't really work for us right now, so what we're going to do is make a thing called a thunk. A thunk is just a function which takes a normal callback generating function and just returns a function instead. I'm not going to go into too much of the details, partly because I always make it terribly confused, and also because you can read the source code to thunkify yourselves on the internet. It is only 5 lines long. So all we're doing here is we're requiring the excellent thunkify module. It's a function that returns a callback rather than calling it a callback. And we're going to wrap up our geocoder and our loomap API in it. Okay, so all we've done is make those things which return the callback rather than waiting for the callback to be called. And they are the things which are going to... You don't believe me. I don't think you believe me. I'm going to run it to prove that it really works. Okay, so it really does work. Spinning Jenny is coordinating the effects of our generator. She's passed an instantiated version of the generator. She calls the next function on it and sees if she gets a result. Then she analyzes the result to see if she's finished yet, and if she's not, she just passes that value back into the generator, which is where this happens. We yield the result of the geocoding and assign it to a variable. And then, if she's not done, she recurses and keeps doing that until the generator has finished its execution and is happy that it's complete. Are you with me?
Mm-hmm.
Okay, that's the hard bit. It's the only hard bit. This is scrappy, right? Our spinning function is a bit loose. There's nowhere where we even look at the results of our callbacks to see if any errors occurred. I mean, I don't care. And also, we can do better. Let's look at Co. So Co is a really nice library, written by T.J. Holloway-Chuk, who is a dude. Anyone heard of Express? Yeah, so he was one of the guys who wrote Express. He's now abandoned us and gone off to GoLand, which apparently is where all the cool kids are going now. But before he left a legacy. And I think Co is the best bit of it, actually. So Co is a library. It's fairly small, and it's designed to do what spinning did in our previous example. It coordinates the actions of generators, but it does it properly, as if a programmer had written it. One of the things it can do, I spoke about thunks a moment ago, and our generator coordinator only knew how to deal with thunks. Co's really cool and can deal with all sorts of stuff. It can deal with promises. Who's heard of promises? Yes. Yeah, I mean promises like in jQuery, promises like in Node, same thing really.
Promises always great.
So here, just to prove that this is true, we're going to promisify our Great British Public Toilet Map API, and we're going to thunkify our geocode API. So we're doing two different things to those, and we're going to demonstrate that actually Co doesn't give a damn. Okay, it knows what to do with both of those things. It knows what to do with thunks, and it knows what to do with promises. It also knows how to throw errors back onto the generator. I'll explain why that's important in a moment. I don't think I wrote an example, but I'll explain it badly probably, but I will explain it. So we're going to call Co just as we called spinning. We're going to pass in a generator function, because Co's a bit cleverer, and it understands that we might not actually want to instantiate our generator at the same time. So it's going to return something which we can call, it's going to pass our arguments through to the generator function that we gave it. Okay, we're going to invoke that. We're doing a bit more clever stuff here. New JavaScript syntax, everyone know that you can call map on an array? Can anyone explain what it does?
Loops over each item and returns it into a single item?
Yeah, so map on an array will return a new array, which is the product of calling a function on each item in the original array. In this case, we're just going to return a call to our thunked or promised function. Okay? So coords in this case is going to be, the thing that we're going to yield is going to be an array. Okay, it's going to be an array in this case of two function calls, one with each postcode to the geocoder. Now that's kind of cool, because actually what's happening, Co is going to execute those requests and manage those requests in parallel. Okay? It's not going to yield until both of those requests have completed. Okay? Until both those promises or thunks have been fulfilled. It's going to wait until everything in that array has been resolved in one way or another before it yields back and passes back and we get our coordinates. So at that point, coords is going to be an array of coordinates for each of the arguments that we passed in. We're going to do the same thing with loos. We could do this, we could mix and match styles here if we wanted. Co wouldn't care if the array wasn't homogeneous. You know, for example, if some of the items in the array were promises and some of them were thunks. Some of them could even be just values, okay, which it will understand it doesn't have to do anything to resolve. And eventually, once all of those promises and thunks and whatnots have been resolved, it will pass back into the generator using the value passing facilities of next, the completed array of asynchronous actions. Okay? And so we're going to end up with an array of coordinates, and delightfully, of course, we can get an array of loos, because that will all have happened before we proceed to the next line, as if by magic. Okay. And then, I mean, to be honest, most of this function is formatting the results, right? You know, is iterating over those postcodes and building up our result object. We've got no callbacks here. If we were really dudish and we enabled some more ES6 functions which aren't even in Harmony yet, we could do something kind of exciting like, we could do, have you ever seen this? Anyone heard of a fat arrow function?
Fat arrow function.
Yeah.
Anonymous function is yes.
Yeah, a bit like a lambda, I guess. So, in the near future, you'll be able to do this instead. Don't be fooled, it's just syntactic sugar, really. There's some JavaScripty stuff to do with scope bindings going on in there as well, but ultimately all it's doing is defining an anonymous inline function in a slightly shorter form. But it is quite nice to get rid of some cruft. I can't do
like
that.
PHP.
Yeah, yeah. There's a downside to everything, right? But we can't do that next because that's not in V8 at the moment. But one day maybe. What have I fumbled? Oh,
More undos.
More Zs. That's what I need. Okay. Are you still with me? Okay, this could be worse. So that's code. That's the code library. We can do other stuff here. Now, I mean, my API never returns an error. You can imagine why that might be. But if it did, we might want to wrap some of that in a try-catch. Because Co knows how to handle errors. So we could try to resolve all of those geographic coordinates and try to get the list of loos. And we could catch the error, and the E that was passed to our catch would be whatever went wrong. And our stack trace would point to the yield line where it went wrong as well. So I mean, this is getting a bit esoteric, but sometimes it's very difficult in Node. If you've got a lot of nested callbacks, you lose the scope of your stack trace, and you don't really quite know what's gone wrong. You have to kind of guess, because you've lost a lot of the context of the context of your operation. Whereas here, we can write asynchronous I/O as if it were kind of procedural, straight down the line blocking code. You can use try-catch. Who's ever used try-catch in JavaScript? Okay, well, I thought, yeah, good. I spent ages thinking that it was just a bad thing to do because it would never work. So that's the code library. We're making good progress. So I'm going to introduce you to an entire web application stack built around code. The same guy that wrote this, along with some conspirators, has written a framework called Koa, koa.js. It is essentially it's a replacement for Express, written by the same team, who got bored before they finished Express 4 and moved on. Express 4 is good, it's finished, but Koa is nicer. And it looks a bit like this. So we grab the library, Koa. Just to give you a sort of conceptual overview of what Koa is for, it's for building web servers, just like Express is. It comes with many fewer batteries included. Yes, that's a question.
The previous slide you didn't run it.
Didn't I? Isn't it just that the result was the same as the slide before? Hang on, let's run it. Yeah, look, it does work.
That's faster.
Yeah,
Oh,
0.6.
Yeah, well, it should be, shouldn't it? Because those requests are being dispatched in parallel. So it should be a bit quicker. Also, probably because the caches are all on my API. And also because it's not a cheap Heroku instance, so it might have gone to sleep while we were talking. Koa. Lightweight web stack, based around the concept of middleware. I've never really understood what middleware really is. I know it's in the middle somewhere, and I guess it's somewhere between the browser and the database, somewhere. But I do understand the way that Koa uses its middleware, and how you register it, and what happens. And I think it's kind of cool. Because when I looked at Express, you've got lots of, you pass lots of callbacks, and you have to resolve things, and you call next. You still do that. I'm not sure about the obsession with next. But there always seem to be problems about error handling, about the order of execution. But in Koa, it's really nice because stuff flows down through your middleware, and then like proper middleware, it flows all the way back up again. So it feels like a kind of input-output box where the input is an HTTP request, and the HTTP request goes all the way down the middleware stack, and then it bounces off the bottom and comes all the way back out as a response, right? Which kind of feels quite nice and logical. Let's see how it works. What have we got? We've got Koa. We make a Koa application just by calling it. So we've returned an app instance. I wrapped up all the stuff we did earlier in a single call just to kind of try and keep this a bit cleaner. So P has got a geocoder and P has got a GBPTM, and they're both wrapped in Bluebird. Bluebird's an excellent promise library if you're ever reaching for one. I think it's cool, but there are plenty of others out there. So P is going to have, well, you can see, look, it's got geocode and it's got GBPTM on it, and they've both been wrapped in Bluebird promises so that Koa will understand them. And we're going to register a piece of middleware, and in Koa, pieces of middleware are generator functions. Okay? And this one is going to do exactly what we've done before, really. It's going to find a list of postcodes. This time it's going to get them in a really embarrassing and amateurish fashion from the URL. And it's going to do pretty much what we've done before. And instead of console logging the result, we're going to assign the result to the body of Koa's context object. Context is bound. It is this. It is the context of the request-response cycle. And it's got a few nice, convenient shortcuts if you want to know about the headers, if you want to investigate the request and response. This is actually one of the nice things they've done. In Express, the request and response are plain Node HTTP request and response objects, which are very glorious things, and they're still being used under the hood here, but they can be a bit awkward to work with in places. But once they've made that decision that that's what they were going to do, they couldn't really alter it very much. And all of a sudden they saw people like monkey patching the HTTP module in order to get it to do the things they want. In Koa, they've wrapped that. You can still get to those request and response objects, but they're just buried a bit deeper, and most of the time you don't really need them. So we're going to assign the result onto body, and Koa's going to figure out the rest. It knows about JSON, it knows about stuff. So I'm going to run that. I'm not going to run it in the weird build process in Sublime. I'm going to get the wrong key binding. Hang on. This was the other mistake. Oh yeah, Alt-Tab, right. So we're going to run that. We're going to run node harmony flag. We're going to pass it our web app. It's going to run that because I'm too lazy. It doesn't even tell us it's alive. I'm going to clear the terminal. And then, so we're going to send an HTTP request to localhost port 3000, which is where I bound the running Koa app. And we're going to give it our 2 postcodes, right? Everyone see how that's going to work? And it is going to work. You can see we've got all the normal goodness. We've got an HTTP 200, but because my theme is so dark, you can't see it. It knows how to do HTTP, and it has given us a JSON body response with the data we're expecting in it. Magic. That's good, right? Pretty simple. I think it would be most interesting to think about how to enhance that with maybe one more thing. The classic example for middleware in Koa is to log the response time. So that's what we're going to do. We're going to use an extra piece of middleware. Here's the old one. Look, you can see it's pretty much the same. I might have changed it. No, I didn't really even change it at all. You don't have to do stuff like this awful splitting of paths and so on. There are lots of nice routers that you can use as a choice, of about a dozen already, which will extract parameters from the URL for you with pattern matching and do all the rest of the stuff that you might expect in any grown-up web framework. But we haven't installed anything extra here. We're just using like bare bones stuff. But this middleware is interesting because it demonstrates the next thing. So we said that the request would flow into the middleware, flow all the way down, and then come all the way back up, right? That's exactly what's happening. The request is going to come in through this piece of middleware. The request, the whole context of the operation, this is going to come in to the execution of this generated function. We're going to wake up and we're going to say, okay, let's make date. And we're going to assign a date string to the value, to the start of the request. That is the first time we saw it come in. Okay? Then we're going to yield next. And that's our way of telling Co and Koa that we're done for now. Okay? And that it can get on with passing this context all the way down to the stack. So at that point, it's going to flow into the next piece of registered middleware, where we're going to go off and get our toilets and assign them to the body of the response. And then it's going to hit the bottom, and then it's going to bounce back up. This hasn't got anything left to do. It hasn't yielded next at any point, so Soco's just treating it as a naive piece of middleware, which is going to activate once. We're going to flow all the way back up, and we're going to resume the operation of this piece of middleware where we left off. At which point, we can make a new date, which is and subtract it from the old date, and set the response time header to the number of milliseconds which has elapsed between the time when this middleware saw the request on the way down and the time when this middleware saw the request on the way up. You're with me? I see nodding, but you might be sleeping. I will go and run it. Yeah, you have yielded. We can't use the old one. We'll need, what do I call it? Oh, yeah. And lo, we have the X response time header representing the length of time it took us to process the entire request. And I have been talking for just under 45 minutes. I'm going to stop. Questions? I don't know any more answers. You've got everything I know. Yes, Anders.
You said it goes to the bottom and comes back up again.
Yeah.
If you had 3,
yeah.
1, 2, 3, does it go? It goes 1, 2, 3, and then does it go 3, 2, 1, or just
yeah.
3? It goes back up again.
Yeah, yeah. So in the order you register them, which I still think is a bit dangerous and weird, but yes, you register them as a stack. It's a middleware stack, and there are utilities for manipulating the middleware stack. There's lovely stuff called Koa Compose, which lets you take existing pieces of middleware or your own bits of middleware and compose them into single middleware functions. So you can branch the request out and do a load of stuff, then bring it back in and then pipe it back down again. There's lots of stuff like that. Yeah, that's good. Oh, the other thing you should know, which I forgot, totally irrelevant to your question, is that, I was talking about all the things that code can understand when you yield them, that it can understand plain values and thunks and whatnot. You can yield generators. Yes, turtles all the way down.
That's a bit inception.
Very inception.
Yeah.
So I'm assuming that Koa is not ready for production.
I'm using it in production. Yes, why not? Why not?
It's a stable version of that.
Yeah, but what does that really mean? Because they haven't put a
It's
number on
no
it.
point anyway.
It's no point anyway.
If you're worried
I mean,
about a restart,
really, I think people worry too much about that stuff.
This isn't so much a question. I just want to thank you for giving me an insight into what you were doing on that project we were working on together, whilst I was drawing pictures of toilets.
Someone ask a question.
Yeah, oh, don't. I was afraid of this.
Are you getting the train over?
No, I'm staying in town.
Just one stop up the road.
Good answer, Rick.
You always go next. Can you go previous?
No,
no.
I don't see why not. You mean yes, you could actually. You could ask Koa about its middleware stack, and then say what was the bit of middleware before me, and maybe I can talk to that a bit before carrying on. I guess you could. I'm not quite sure, but I don't think you can unwind. I don't know.
Wrong.
Frank?
I have a pedantic observation.
I'm using tab spacing. What more do you want?
No. This is not a critique. Well, so the powers that be have decided that making custom headers start with X was ultimately a bad idea because they couldn't then standardize them.
Yeah, I think it should just be the response time header.
Exactly.
Standardized custom header.
Standardized headers that are used a lot into custom headers use a lot into standard headers, like we use a lot, like auth token and whatnot.
Yeah, I think the X
PHP has got lots of
custom
answer for
headers
as well,
is
which is
pointless.
powered by.
I think headers should be a free form.
Full stop.
No, PHP is lovely.
It's like brick web components. I mean, X is from
That really was it, unless there are any more questions.
So do you regularly use generators?
I've been regularly using them. on
It's
one
because
project, and
He's used it in a live project, yeah.
yeah, and I would I'm considering using Tracer just so I can use them in the client as well because I'm enjoying them so much. Like really being able to line up a whole stack of asynchronous actions. I mean, even without code, which is magic with its kind of flexibility. Like you can yield an object, okay, which has properties and its values are generators or its values are promises, and when it comes back, it's an object with the same properties, but their values have all been filled out and finished off. That's magic. And being able to catch exceptions and know where they came from. Yeah, I mean, I think this is a really good way forward. I like the fact that it's kind of, it's not too opinionated. Opinionated, that's a rubbish word, isn't it? What I mean is that it doesn't care whether you use funcs or promises, and it doesn't really care all that much about the promise implementation, and no one's going to get upset if it's not A+ or energy efficient or whatever it is. But you can just use all of those different things. You can mix and match libraries. I mean, things like using Mongoose, which is a nice Mongo wrapper, with Koa. It's really easy, even though there are bits of Mongoose. Most of Mongoose responds with promises most of the time, except when you try and use something like aggregation stuff, where they've kind of forgotten to do that bit yet. I think they might have done it by now, but last time I looked, they were thinking about it. But then you just wrap that bit in a thunk and carry on as if nothing had happened. It's really good. Yeah, I'm enjoying it.
So given the browser support, are you only doing this in Node on the server side?
That's my official line.
Is Koa smart enough to work with the old Express middleware, or are we wrapping?
Yeah, I have used bits of Express middleware when I couldn't find anything else, and so there are. I mean, obviously, it's not, you don't get all the generatory goodness, but with some of the simpler bits of middleware, yes, you can just plug them in. I mean, to be honest, most of the bits which are worth using, someone's written Koa-based stuff. There's quite a good list of middleware if you go to Koa.js. You can see the list of stuff that you might want to use, but none of it's included. But we have NPM for that, right? Good, let's drink.